you're ready for another tool in the tool belt, aren't you? You want to see what else we're going to use to solve a polynomial. Well, before I give you that tool, let's kind of take a little stock of where we've been and where we're going to go. So we kind of started with a question like this on the very first day. Is x equals -5, is that a root for this big old polynomial? And remember, your hammer, your most fundamental tool, says that all you got to do is plug in -5. And when you plug in -5, you find indeed that it comes out to equal 0. So yeah, it's a root. But we don't. We have some other tools that we could use, and I guess if we really wanted to, we could use something more of a power tool. We could make a graph. And when you make a graph using your calculator or Desmos, you would see that the graph surely passes through -5, which we expect to see. And we're probably not surprised to see that it passes through some other roots also. But we can see that -5 is a root. So that's looking good. And of course, we could divide using that factor. But I'm wondering if you kind of felt like we could have divided by something else. Now, I'm not talking about a whole different factor, but I'm talking about kind of a different way to divide. And it really has more to do with just the root itself. Did you feel like that you wanted to divide by just -5? Well, if you did, you were thinking about something known as synthetic division. Now, synthetic division allows us to use just the numbers that go with our polynomial, starting with the root, which I tend to put in a little bracket, but then I'll take my coefficients of my polynomial, and I will drag them down here to become the first line of my synthetic division. And we have ourselves set up real nicely for a process that kids tend to remember and like to use. And why don't we go through that, and then I'll tell you what tool this is. So do you remember, you bring down the 1, and when you bring that down, the process begins by multiplying. You multiply these numbers together, and after you multiply them, we record that value in this second line. You add and multiply. You multiply these, you get 20, and then again, we're going to add. So I should have said it more like we multiply and add. We multiply and add. And you multiply one more time, you'll multiply 3 and -5. You're going to multiply those, you're going to get -15. And when you add, you get our remainder of 0. Now remember, the numbers that we got here, the so to speak 1, -4, and 3, those actually represent a depressed polynomial. It's not depressed because it's sad, but it's depressed because its degree has gone down by 1. And so this 1 is going to be the coefficient on a degree of 2. This -4 is going to be the coefficient on just x, and then we end up with 3. So our depressed polynomial is known as x squared minus 4x plus 3. What can you do with that depressed polynomial? You can do the same thing that you've always done. You can continue to solve it. You could use completing the square. You could use the quadratic formula. Of course, I hope that you don't use either of those, because it's just a simple factoring problem. Two numbers that multiply to be negative or positive 3 and add to be -4. And we have our remaining roots, which would be, of course, x equals 3 and 1. So, synthetic division, a really nice way to find or to depress a polynomial so that we can get it down to a smaller, more factorable version is that we can solve for those 3 roots. By the way, those other roots on the graph, as I'm sure you realize, are the other roots that we found. So yeah, you could have found them on that graph, but we want to make sure that we can use synthetic division when necessary. So division, it's something that sort of breaks down a polynomial. And we talked about yesterday a block plane. That's something that sort of surfaces or pairs down. But what if I have more like a power plane? A power plane, a joiner, or a power planer. I like this joiner. In fact, I wish I had one that was this big, but We call this a jointer. It's a tool that can actually give you a flat surface, a flat edge, and it's definitely a faster way to do division. So that's why we'll use that for synthetic division. All right, we're getting closer to sort of the super problem. And the last couple problems we do are going to be just like that. Basically, find the roots. Find the roots, use the tools, and use them wisely, because, well, you don't want to cut a finger off or end up with a wrong answer. So here we go. We've got a big old polynomial, and the directions just say to find the roots. Put a little smiley face on that because that makes people happier. But what are you going to do? What are you going to do? Where are you going to start? Well, that's kind of a hint. You need some starting roots, right? So the place that we start, the only place that we can go to get these roots would be a graph. Okay, now when you go to the graph, you're going to only be able to see the real roots, but I would say at least you're going to be able to see something. Now, I encourage you to graph this because the sketch that I'm about to draw here isn't really what it looks like on your calculator, and your calculator just looks like two straight lines. But you want to realize that those two straight lines are intersecting the x-axis, and that's where we start. So we see -5 on our graph, and just so you realize, we also see 3. So do you realize what you're going to do with those roots? Yeah, you're going to divide. That's what's expected. You're going to synthetically divide, and you can start to grab the coefficients of your polynomial. Hey, don't forget, if one of these x's were missing, you would have to put a 0 in there as a coefficient. But I have all my x's starting with 4 all the way down to no x. But again, you may need to put a 0 in here as a placeholder. Now, when you do the synthetic division, you drop down the 1 and you multiply, and you add, and you multiply, and you add. And you anticipate a remainder of 0. I will say that if you don't get a remainder of 0, it either means that you divided wrong, or maybe you picked a root that's not actually a root. So you can't go any further unless you get a remainder of 0. Now, speaking of going further, you want to make sure that you pick up where you left off. You want to make sure that you keep depressing. So yes, I'm going to divide by 3, but I'm going to divide it into where I left off. That way I can keep depressing my polynomial down to a lower exponent. Okay, when you multiply and add, you end up with another remainder of 0. And something I want you to remember is that your depressed polynomial, I should say the goal of your depressed polynomial, is to get down to something that you can solve, to get down to at least an x squared. Now that's what we did here, since we started with x to the 4th and we divided twice. We're now down to an x squared. And that means, of course, 1x squared plus 0x plus 4. Now that depressed polynomial is solvable, right? Right, you just want to set it equal to 0. And, oh, you mean just kind of like solve it? You like subtract 4 and take the square root of -4? Yes, that's what I mean. Okay, so don't do anything funny. Don't use the quadratic formula. You don't need to. Don't factor it because you can't. But here we have a nice little plus or minus 2i. Now you were expecting to get 2 more answers, right? Okay, we started with with the degree 4, and we now have a total of 4 answers, which we want to list at some place, at some part of your notes or your quiz. You want to make sure that you list all 4 of those answers. We got some of them off the graph, and we, of course, got some of them by using polynomial or synthetic division. Are we having fun yet? Okay, we're just about there. We don't have any more tools, but we do have one more use of a tool. I want you to see through this problem that we can actually use synthetic division with an imaginary number. Yep, you can actually use synthetic division with an imaginary number. Here I'm giving you a polynomial, and I'm giving you a root that the root of x equals I. Okay, now the point behind this is to show you, so that you can use this as an appropriate time, that you can divide by I. If you just trust it, if you just follow the rules of I, you'll get a remainder of 0. It's pretty neat. Okay, so you ready? I'm going to take 1 times I. Of course, you write that down in that middle line. Now, what's the next thing to do here? You add, right? You add. Now, when you add, you get -2 plus I. Now, -2 plus I is a quantity, and that quantity is going to get multiplied to I. So yeah, you got to do the distributive property. Okay, let's do it carefully. -2 times I is -2I. I times I, right, that's I squared. Oh wait, I squared, that equals -1. Now, if it's all right with you, I'm going to skip writing I squared. I'm just going to write it as -1. Okay, because now what we're going to do, we're going to add. We're going to add, and if you look carefully, when you add these together, the 1 and -1 cancel out. Oh, that's convenient. That leaves us with just -2I. Well, -2I is going to get multiplied by I. Are you doing that? That's -2I squared. Now, it's all right with me if you leave out the I squared, because you know that I squared equals -1, and right away you can change this I squared to be -1 times -2, which is +2. Okay, now be careful, because I'm not just making it work. It works. You get a remainder of 0. We end up with +2 and -2 to be 0. Now we're kind of left with a goofy, depressed polynomial. And we don't want to stay at that. We don't want to stay at that expression. Instead, what we want to remember is that if I is a root, that means that -I is a root. It's always going to come in a pair. So, yep, I'm going to I'm going to divide again, but this time I'm going to divide by -I. All right, now check this out. You drop down your 1, you multiply these together. That gives you -I. You add -2 plus I and -I. Yep, it cancels out to just be -2. We get these i's to cancel out, so we're going to multiply. We're going to multiply these together. We don't get I squared, but we do get 2 negatives that make a positive, and conveniently, but actually mathematically, it ends up being +2I, which is going to add to be a remainder of 0. Listen, when you divide by imaginary numbers, you're always going to get a remainder of 0 if they're roots. So it was destined to work. Now, this is a depressed polynomial. Sometimes it can be a little bit confusing because it's very depressed. It's down to just x minus 2. And x minus 2 equals 0. We don't need to get too fancy with that. I hope you just say x equals 2, which gives us our other root. Okay, so our roots are 2 and plus or minus I. Now, if we were in class, somebody would probably ask, hey, Mr. Naylor, I could have found that answer like a few minutes ago. I could have graphed it, Mr. Naylor, I could have graphed it. And I say to you, that's fine, I could have graphed it also. Okay, and I could have got the root of 2, and then I could have said that my 2 imaginary numbers have to go together. But the process of dividing is something I want you to be able to do. Okay, and to kind of show you that, I'm going to let you work through this exit ticket.
So nothing too crazy going on with this exit question. Just wanted to make sure you realize that, yes, you have to start by dividing by these imaginary roots, and in fact, you're going to have to divide by both. And you just want to pick up where you left off when it's time for the second division. But the main thing I want to mention here is that this thing is certainly of degree 4. You're going to divide twice, so you're going to end up with something of degree 2. It's going to be some type of quadratic. So when you get that quadratic, okay, I want you to pick very carefully a tool in your tool belt to be able to solve for the remaining roots. You should not be using a power drill. You should not be graphing to find your last two roots. We want to see these answers as a conjugate, using a square root as appropriate. And, well, you can list all four roots for that final answer. Once you finish the exit question, don't forget there's still a regular homework helper, and that'll wrap up at least the first part of this chapter on solving polynomial equations. Next time we meet, we'll be talking about solving another type of equation. All right, but that's for the next time.